Hello dear students, welcome to BYJU'S Exam Prep, and I welcome all for this GATE PYQ series of IIT Kanpur, and today's subject is algorithms. So we try to take the GATE PYQs of, one second, am I live? Okay, yeah, I am live. Fine. I think it's not started. Okay, it's fine. Fine. So let me start with the GATE PYQs of algorithm subject, and mostly 2001, 2007 and 2015. These years GATE PYQs we try to solve, my dear friends. Some of the PYQs, okay. And this is about me, myself, Sridhar Dhulipala. I am having 20 plus years of teaching experience, and my qualifications are MTech Saka from IIT Karnataka, Surathkal, and MSc Mathematics from JNTU, Hyderabad. Okay, and these are all my areas of expertise. Under BYJU'S Exam Prep app, the category name, please note it, learn with video lessons. You can find all these subjects which were recorded by me. Okay, and I am associated with BYJU'S from past 1+ years, and we were doing this unique type of content called recorded GATE content, my dear friends. We created, visualized animated content for you people. Okay, so you can see all these subjects which were recorded by me under this BYJU'S Exam Prep app, learn with video lessons category, my dear friends. So let us start with previous year GATE questions of algorithms which were asked from IIT Kanpur. Okay, so this is a question which was asked in year 2007, and this is a greedy algorithm, Huffman coding problem, my dear friends. So let us start with a simple, interesting problem, Huffman coding problem. See, the idea of Huffman coding problem is we want to use the variable length code to encode these letters, okay, because the fellows which are having higher frequency, which are mostly used, okay, their code length must be smaller, and the fellows or the letters which are having less frequency, very less used. So you can use the variable length or very big length code for them, my dear friends. Okay, so that is the basic idea. Hi AB, let us solve problems. Very good evening, sir. So let us start with this problem, my dear friends. Now let me tell you, actually recently I done this optimal merge pattern. If you attended that particular lecture, this would be much easier for you because the logic would be same, sir. Okay, instead of drawing every tree, we try to identify how can you merge two small elements, and finally we construct the tree. From there we create Huffman coding, my dear friends. Okay, so let me solve the problem. See, here not many details are discussed. We are going to solve the problems, my dear friends. Okay, if you already know the topic, that's wonderful. Otherwise also you'll understand. Problem solving technique you will definitely understand, sir. But what is Huffman code? All these nonsensical details now I cannot discuss because it is purely solving problem, my dear friend. Very good evening, Mr. Prajwal. Okay, now look at this. Here each letter is having a particular frequency. So we have to arrange these frequencies in increasing order. Actually speaking, non-decreasing order. Non-decreasing means equal fellows together and increasing order. Equal fellows together and increasing order. First you arrange these frequencies, my dear friends, and each letter here denote the leaf node. Actually, when you see this as a binary tree, it is called extended binary tree. The binary tree which you get for this is actually called as extended binary tree, where these are leaf nodes, my dear friends. These elements which you are going to create, they become leaf nodes, my dear friends. So let us solve this. So what is the smallest fellow? These two are the smallest fellows. These two are smallest fellows. So let us create a node for them. E1/32. So the original nodes are denoted by square. And what we do, we combine two nodes to form a new node that is denoted by circle, my dear friends. So we try to denote nodes in two different ways. Generally in extended binary trees, these are called dummy nodes, and the regular nodes are internal nodes, my dear friends. So these are external nodes. These are what? External nodes. Later we combine these fellows to create what is known as internal node of your binary tree, my dear friends. So we can call it as Huffman binary tree without loss of generality, my dear friends. Very good, very good. Nishit Raj, you need to call these, counselors. They'll inform you every details, my dear friends. I think the test series of BYJU'S, it would be of nominal cost, sir. Mostly they'll be launching soon. Already some free tests are conducted. So you can take that particular test series, my dear friends. Okay. It is to, involve many students. Just give me one second, sir. I'll just be back. Just 1 second. There's some small issue. I'll just be back. Just 1 second. Oh, nothing like that. Actually, switch on power switch on karna bhul gaya tha for camera. So that is the only reason. Sorry for that. We'll continue with this. Am I clear? So let us start. Okay, let us start the problem. Now look here, E, then F, because these two fellows are having same value, you put them together. Then next fellow is D, which is 1 by 16. Then C, which is 1 by 8. So we created a small nodes. Okay, generally we denote this original leaf nodes by square nodes, my dear friends. Okay, then B is 1 by 4 and A is 1 by 2, my dear friends. Is that clear? Even for paid course, you have to call, the counselors, my dear friends. Actually, store.byjus.com also you can visit. There also you can purchase. Otherwise, if you join this BYJU'S Exam Prep app, there you will find these counselors. You can talk to them. Okay. So here what happens, they'll guide you from the beginning. It's not like, you purchase, say purchase button and they'll inform you every detail. So here in BYJU'S, things will be done in a very, very detailed manner, my dear friends, those who want to purchase. Okay. So that is about my information. Okay. So generally we are not involved in the sales. So you need to ask the proper salespersons. Okay. Sales in the sense they are the proper people who can guide you properly for purchasing and information about the courses, my dear friends. Okay. Like that. Now look here. What we do is we take the smallest two fellows, we merge them. So what are the smallest two fellows? See here, 1 by 32, 1 by 32. Actually, we are arranging them in non-decreasing order. That is increasing order with equal fellows together. Then this is 1 by 16. Then this is 1 by 8. Then this is 1 by 4. Then this is 1 by 2. What you do is you merge these two fellows. The smallest fellows you merge. Now the new merged fellow is 1 by 32 plus 1 by 32 is 2 by 32, which is 1 by 16, my dear friends. You got 1 by 16. Now again, this new fellow and these old original nodes or the leaf nodes, okay, or dummy nodes, whatever you call them, you arrange them in non-decreasing order. So what is the order now? See, actually original square node, suppose whenever there is a tie, original fellows will come first, the created fellows will come next. That is the order we follow, my dear friends. Okay, that is the order we follow. So here it is 1 by 16, 1 by 16, then it is 1 by 8, then it is 1 by 4, then it is 1 by 2. See, if you understand, you can write this quickly, my dear friends. Then what you do, the smallest fellows, you merge them into single. Means you combine with a new node, okay, or you combine those two fellows. 1 by 16 plus 1 by 16 is how much, sir? 2 by 16, which is 1 by 8. Now what you do, you again arrange them in non-decreasing order. That is 1 by 8, 1 by 8, 1 by 4, 1 by 2. Now again merge them. So what happens? This is 2 by 8, which is 1 by 4, my dear friends. See, the circled fellows are the created nodes and the square fellows are the original nodes. That is the idea which you need to remember, my dear friends. Now what happens? Again you arrange them in the order, that is 1 by 4. After this it is 1 by 4 square 1 and 1 by 4 created 1, then 1 by 2 original 1. Now again two small fellows, you merge them. These two you merge, what you are going to get? 2 by 4, which is 1 by 2 created fellow. Now again arrange them like 1 by 2 original, 1 by 2 created. Now these two small fellows you merge them into 1, which is 1. Now you start creating the tree. See, generally people create so many trees, but instead of that you create like this. With numbers you work, then you create the tree. Then you create the tree, my dear friends. Now let us create the tree. So 1 is the topmost fellow. 1 is the topmost fellow, and 1 is created with fellow with what? 1 square node and 1 created nodes. And the square node of 1 by 2 is what, sir? A12. So let us write that. So the left fellow is A12 or A1 by 2 and the right fellow is 1 by 2. Now you need to tell me how this 1 by 2 is created. It is created with 1 by 4 square and 1 by 4 circle node. 1 by 4 square node means B. So the left side of this would be B 1 by 4 and the right side is created fellow. Am I clear? Now again go back how 1 by 4 is created. 1 by 8 original and 1 by 8 created. 1 by 8 original is C. So this is C 1 by 8 and this is created, so it doesn't have any name. Later on if you want you can give names for them, my dear friends. That is your wish. Then 1 by 8 is created with what? Actually it is straightforward, sir. If you observe, this is straightforward. D 1 by 16, then it is 1 by 16. Now again this is E 1 by 32 and this is F 1 by 32 because these two are directly created by original nodes, that is F 1 by 32. Okay. Now what you do is you just number these left edges and right edges. So every left edge is numbered with 0 and every right edge is numbered with 1. Left edge is labeled with 0 and right edge is labeled with 1. 0 1 0 1 0 1. Actually if you want you can do reverse also. Left edge with 1, right edge with 0 also. But you have to follow uniformly. You have to follow that uniformly. Don't do sometimes left is 0, right is 1, sometimes right is 1. Don't do that. Follow uniformly, my dear friends. Anything is fine, my dear friends. Now you can see the Huffman code for each and every letter. So what is Huffman code for A? Just see the path from root node to that particular node and write down all the labels of the edges, and that will give you the Huffman code for that particular letter A. So for letter A the code would be 0. Similarly, what is the code for B, my dear friends? What is the code for B? Just follow from this how to reach B. 1 0. B is 1 0. How to reach C? 1 1 0. How to reach D? 1 1 1 0. How to reach E? 1 1 1 1 0. How to reach F? All ones. And this is Huffman code, my dear friends. A very simple problem. Okay. Actually, earlier I done one, as I told you now, under exam prep app, I done this free class, optimal merge pattern. If you understand that, both are almost same. The ideas are same, my dear friend. Both will give you extended binary trees. Only thing is there what we need to find is different. Here what we need to find may be different, but the story would be same, my dear friends. Am I clear? Idea is same. Got it? Now this is length. What is the length of this code? 1. What is the length of this code? 2. What is length of this code? 3. What is length of this code? 4. What is length of this code? 5. And length of this code is 5. Okay. Now you can find the total number of bits required. Of course, in this problem he only asked Huffman code, my dear friends. So can you tell me what is the Huffman code for A, B, C, D, E? Which one is correct option? Which one is correct option? Can you tell me? Which one is correct option for this? Can you tell me? Which one is correct option? A was 0, B was 10, C was 110. So 0, 10, 110, 110, 410, 5 ones. So the correct option is A. Direct question, my dear friends. Is that clear? Direct question. Got it? Now the second question which they can ask you is this one. What is the average length of Huffman code for the letters A, B, C, D, E, F? What is the average length? So for average length, the formula is, that is the number of bits to encode. Okay, if you do it, because here the frequencies are given in fractional part. Okay, so the answer would be average length. Instead of, normally what happens, this frequencies will be integers. In that particular case, you can say number of bits required, because here frequencies are given as fractions. You are mentioning it as average length, nothing more than that, my dear friends. So the number of bits or average length required. So average length required is given by the formula. Simply, what is the formula? Sigma frequency of that particular letter into depth of that particular letter in Huffman tree. This is called Huffman tree, sir. In Huffman tree, what is the depth of that particular letter? You have to see that you need to multiply with frequency, my dear friends. Depth need to be multiplied, and depth is nothing but number of characters or number of digits to encode that particular letter. Am I clear? Depth is simply, this is 2, 1, 0. Depth directly you will get it. So directly this is depth, sir. So you just need to multiply frequency with depth and add up. You are going to get required answer, my dear friends. So what is the answer? 1 by 2 into 1, 1 by 4 into 2, 1 by 8 into 3, 1 by 16 into 4, 1 by 32 into 5, and 1 by 32 into 5. Simplify to get the required answer, my dear friends. So what is the answer for this, my dear friends? What is the answer for this? Simple problem. Huffman coding is one of the easiest problem, my dear friend. All the greedy problems are simple. Okay, you can start and you can complete everything within 2 hours. Okay, the entire greedy problems. Even dynamic programming problems are also simple, my dear friends. Only generally people fear with that, but we just need to understand the recurrence relation, apply properly, you will get the answers. Okay, you also have patterns in that. Got it? Done? So what is the answer? What is the answer for this? Anyone solving for me, or I should use calculator for this? We'll take it. Definitely I'll take it, sir. Maybe marathon series or any other important topics, definitely I'll take it. Okay. So I already taken some important topics in algorithms, almost asymptotic notation, okay, and performance evaluation, solving recurrences, how to think recursively. All these sessions I have taken, and if you observe, all the sessions are taken in an orderly manner. Now we can start with sorting techniques or divide and conquer or greedy algorithms or dynamic programming or graph algorithms. So any of the topics now can be taken. Okay. So whatever topics I taken, if you observe, you will see some systematic order. I don't want to take randomly because I don't know what type of audience are coming. Am I clear? Suddenly I start with this, even this IIT, because this is an interesting series. Later on, maybe in the future it would be useful for it to analyze or understand, okay, what type of problem this particular IIT is asking. To analyze that, it would be very useful. Generally, this type of series are useful towards the end. After learning the concept, we should start solving PYQs, my dear friends. Okay, like that. Good. So 1.9375 is the answer for this. Please verify that, sir. Next one. This is a direct question, simple questions. Okay. He given Fn and Gn, two positive functions. Which of the following statement is correct? See, first you compare Fn and Gn, then answers can be easily given, sir. Okay. See, my dear friend, whenever such questions are given, what you do first is cancel out common factors. Cancel out common factors. Okay. Then start with the smallest element here and smallest element here and try to build how they are related. First identify, then try to add up these common elements. That relation you automatically get. And if you observe this n cancel, this log n and this cancel. So here it is n and here it is log n power 9. Now please tell me which one is larger, log n power. Yeah, I will be teaching in every course, sir. Everywhere I will be teaching. I already see, when those who taken the paid course will get all my recorded lectures, which were done in a very, very detailed manner, all the subjects. There also I will be taking, because there are multiple faculty, everyone is efficient, my dear friends, everyone will teach, okay, in a very, very efficient manner. I also teach depending on availability of that particular branch, my dear friends. Here also I am taking classes, in app also I take classes, paid classes I take, async. So we are supposed to take every part, my dear friends, and we are here to help you for sure. Got it? Now you see, you cancel out. Which one is larger? See, my dear friend, there is a relation between a polynomial, okay, a polynomial and a logarithmic. Always polynomial fellow dominates, okay, we can write n power b dominates log n power anything, where a, b are positive real numbers, my dear friends. See, this fellow is always smaller than n power b. B can be any positive real number, my dear friends. Even n power 0.01 also you put it, that dominates log power anything. Am I clear? See, generally, even if base is not mentioned, you can take it as 2, because base of logarithm does not matter asymptotically. Because base of logarithm does not matter asymptotically, you can ignore the base, my dear friends. Power of exponent matters, but base of logarithm does not matter asymptotically. See, here we are talking about asymptotic complexity, not about regular complexity, my dear friends. You need to understand that. Okay. So when it is not mentioned, you can take default in computer science, especially when you are talking about algorithms, default base you can take it as 2, my dear friends. There is nothing wrong. Okay. हाँ, recorded course मिल सकता है. You need to talk to that particular counselor, sir. See, as I told you, we are faculty. We'll tell you about our courses, but in what way they are sold exactly, you need to talk to our counselors for that, sir. Okay. Recorded lectures, actually for algorithms I done in a more detailed manner. Even asymptotic analysis I done it in a very detailed manner, my dear friends. All the results I try to prove. So I done it in a way, because generally it is not possible in live classes because it disturbs people. There I try to do in a little elaborated manner, my dear friends. Okay. Yeah. Got it? Now, obviously, this fellow is smaller than this. This log n power 9 is asymptotically smaller than n. Now, if you multiply on both sides with log, it is log power 10 ho jayega, and this will be n log n ho jayega. Now, I multiply on both sides with n. It is n log n power 10 ho jayega, and this is n square log n ho jayega. So, this is your what? Gn is asymptotically smaller than Fn. Gn is asymptotically smaller than Fn. Done. So, now using this relation, you have to find what is correct answer. Gn is asymptotically smaller than Fn. Okay. Of course, it may be, see, asymptotically smaller. Gn is asymptotically smaller than Fn. So, you can write Gn is big O of Fn, that is bounded above asymptotic tight upper bound. Fn is tight upper bound for Gn. Am I clear? So, Gn is big O of Fn is correct, but Fn is big O of Gn is not correct. So, this is the correct answer, my dear friend. Fn is bounded above by Gn is wrong. Fn is not bounded above by Gn is correct, but Gn is not bounded above by Fn is wrong. Because of that, this is wrong option. So, this is the correct option. Fn is big O of Gn is right, no, wrong, sorry. And Gn is big O of Fn is right, but because of this, it is failed. So, what is the correct option? Option C, my dear friends. It's a straightforward, simple question, my dear friends. Okay, we can solve it simple with simple mathematics also, my dear friends. Got it? This is one very important problem. Actually, see, my dear friend, when you have two functions, okay, generally they compare two functions. So, here we need to understand that we cannot compare every two functions. There is no law of trichotomy. There is no law of trichotomy. See, what do you mean by trichotomy? Suppose in numbers, when you take two numbers, either a should be less than b, or a should be equal to b, or a should be greater than b. But this law of trichotomy doesn't exist between these functions asymptotically, my dear friends. This law of trichotomy does not exist. This is law of trichotomy, sir. But there is no law of trichotomy. That is, if you give two functions, you cannot say that either f should be greater than g, or f equal to g, or f is asymptotically larger than g. We cannot say this, my dear friends. We cannot say this. For numbers, it may happen, but for functions, it doesn't happen, my dear friends. You can have two functions, you cannot compare them. You can have two functions, you cannot compare them. And this is actually example we give for explaining the idea that there is no law of trichotomy between functions. Okay, and this is one of the beautiful examples, sir. You consider this n power 1 plus sin n. Now you all know that sin n value always lies between minus 1 to plus 1. Add 1 throughout. So 1, if you add minus 1 plus 1, okay, 1 plus sin n, 1 plus 1. So that is 0 less than or equal to 1 plus sin n less than or equal to 2. Am I clear? See, sin n value always lies between minus 1 to plus 1. Therefore, 1 plus sin n value lies between 0 and 2. So as n approaches infinity, what is the halat of sin n? What can you say about sin n? What can we say about sin n? You can't say anything. You can't say it is 1. You can't say it is minus 1. It oscillates between minus 1 and plus 1. It oscillates between minus 1 and plus 1. So what about 1 plus sin n? This fellow oscillates between 0 and 2. This fellow oscillates between 0 and 2, my dear friend. This fellow oscillates between 0 and 2. Therefore, as n approaching infinity, that is large values of n, or asymptotically, what is the halat of n power 1 plus sin n? What is the halat of n power 1 plus sin n? What can you say about n power 1 plus sin n? This fellow oscillates between n power 0, that is 1, and n square. It is not fixed. It can be anything between 1 and n square. Suppose if it is 1, it is smaller than n. Suppose if it is n square, it is larger than fn. But you can't say that because sin n एक जगह बैठने वाला नहीं है, वो oscillate करेगा. So you cannot catch it. So what happens? You cannot compare these two fellows. You cannot compare. Therefore, fn and gn cannot be compared. Hope you understand. This is one of the important. Okay. See, it's not both true, sir. Neither of them true. You can't say this. See, it has to be true for after some value of n. It has to be true always. See, what do you mean by fn is big O of gn? Fn should be less than or equal to some constant time of gn for all n greater than or equal to n naught. I done this asymptotic notation in a very detailed manner, my dear friends, because most of the students have trouble with that mathematically. So I done that for you people. Please go through that. So this will not happen because sometimes this is larger, sometimes this is larger. You cannot find any n naught, you cannot find it. So no, neither is true. Am I clear? So that is very, very important problem, my dear friends. See, actually, here I explained, but actually by looking at this problem, this is a standard example. This is a standard example to say that there is no relation. We cannot relate these two, or we cannot compare these two functions to say that. That is, there is no law of trichotomy. This is the standard example. You can take one more example, n power 1 plus cos n also you can take. Why only sin n? Why to trouble only sin n? Cos n also is same. Am I clear? But in every book you find 1 plus sin n, they take it as standard. Anything you can take which oscillates, that troubles you like that. Am I clear? Anything which troubles, you can do it. So those who know calculus, they know much better about this. Otherwise, what happens? You will have a little difficulty, my dear friends. That's it. Got it? Now, this is the interesting problem. This is also GATE question which was asked in IIT Kanpur 2007 GATE paper. The number of comparisons made in the execution of the for loop. See, there are two types of questions, complexity, but here number of comparisons. How many times this is compared? You have to say. So let us see this problem. Very simple, sir. See, j value starts from where, sir? It starts 1. Every time its value is multiplied with 2. So next time it becomes 2. Next time it becomes 2 square, and like that. How long you continue? You have to continue till this value is less than or equal to n. When you get that 10, let us say at kth term. In kth term, I pray God that this value, whatever I get, is less than or equal to n. Let me assume that. Now, it's not log n, it has to be exact number of comparisons. See, if they ask you complexity, that is theta log n. Blindly you can say that. Theta log n you can blindly say, but it is saying number of comparisons. You have to do this mathematics properly. Sir. Now kth term, see when it is a geometric progression, what is kth term? The kth term is given by, kth term of geometric progression is given by 2 power k minus 1, and this should be less than or equal to n. Therefore, k minus 1 should be less than or equal to log n to the base 2. K minus 1 should be less than or equal to log n to the base 2. Now see, this is interesting, this is important. If you are finding some integer value, because k has to be integer only, na? K means what? Kth term. You cannot have 2.1 term, 2.2, it has to be integer. So you want some value less than or equal to this, which is integer, means you have to take floor of it. So you can write this happily like this. You can write this happily like k minus 1 equal to floor of this, log n to the base 2. What is floor, sir? What is floor of x? Greatest integer less than or equal to this. So this k minus 1 is the greatest integer which is less than or equal to log n to the base 2. So k minus 1 should be log n to the base 2 floor. So what is k? It is log n to the base 2 plus 1, my dear friends. So this is the correct, perfect answer. Oh, you want me to repeat this? Okay. For you repeating, let us repeat it. See, my dear friend, j value started at 1, and as long as j less than or equal to n, you are entering the loop, and every time j means j into 2, that is, it is multiplied with 2. So next time j value becomes 2. 2 less than or equal to n, you enter the loop. Next time j multiplied with 2, 2 into 2, 2 square. Again you enter the loop, multiplied with 2, 2 into 2, that means 2 square into 2, 2 cube. You have to continue. How long? How long you have to continue? Don't know. So let us say, let us assume that in kth term, okay, my value may be less than or equal to n. After this, I am coming out. So up to kth term, I am doing it. Up to kth term, I am doing it, sir. Up to kth term, I am doing. What is kth term of geometric progression? Kth term is 2 power k. This is called geometric progression or geometric sequence, my dear friends. 2 power k minus 1 should be less than or equal to n, not log n, n. So what is k minus 1? That is log n to the base 2. Now whenever you are looking for some integer value less than or equal to something, whenever you are looking for integer value less than or equal to something, just take floor, it becomes equal. So it becomes equal if you take floor of it. Suppose if it is this one, if it is this one, you have to take seal of it. It becomes equal to that. You have to take seal of it. See, you are looking for integer value less than or equal to something. Floor you take it, it becomes equal. That floor will take care of that. Floor will take care of that. Am I clear? Like that. Now what is k? Log n to the base 2 plus 1. Perfect on this part. Got it, Sanchita Das? Am I clear, sir? Am I clear? Thank you, sir. You're welcome. Next question, same, based on performance evaluation. Which one of the following most closely approximate the return value of the function 1? So return value is what, sir? Q. So he's asking what is the closest approximation of Q value? Because this function is returning what? Q. You have to say what is the Q value at the end of this function, or by the end function call is completed. Okay, when you come to the last step or the last line, what is the value of Q? Okay, so let us solve this. Simple problem. Now look here, some variables are defined. Q is initially 0, sir. What is the value of Q? Q is initially 0. Now I value the counter variable 1 to n. I is equal to 1 to n. You repeat the process. See here, what is the process? This is the process, sir. So let us see for I is equal to 1, what is the fate? Let us understand. Because for I equal to 2, similar process happens. For I is equal to 1, p value initially is 0. P value is 0. Now look here, j varies from n to 1 in steps of by 2. If you remember, okay, if you attended, remember this as rule now. If you already attended, you should know it. N to 1, every time the value is divided by 2, the number of steps taken would be log n, my dear friends. How many steps taken, sir? Log n. Am I clear? Log n. So what is happening, sir? This p is incremented how many times? How many times this loop iterates? The loop iterates how many times? Log n times. So p value initially 0, it is incremented how many times? Log n times. So by the end of this loop, the p value would be log n to the base 2, my dear friends. Very good, sir. P value will be log n to the base 2, or simply LGN you write, that is log n to the base 2 only. Now here, k varies from 1 to p, that is k varies from 1 to log n, and what is happening? And you are reaching this log n in steps of or in multiples of 2. You are reaching this in multiples of 2. Okay? And that many times q will be incremented. That many times q will be incremented. So how many times this loop iterates, that many times q will be incremented. So the number of times this loop iterates, that is the value of q, simply. So how many times this iterates, sir? Because you are going from 1, 2 and so on up to log n. You are going from 1, 2 and so on up to log n. So let us assume that it is kth term. So 2 power k should be equal to log n. What should be k? K should be log n. So how many times this loop iterates, sir? This loop iterates log n. That many times q increments. That many times q increments. So by the end of this, that is first iteration, for I is equal to 1, that is for the first iteration of I, the q value will be log n. This is for I is equal to 1, it is q value is log n. Again for I is equal to 2, q value again incremented log n times, that is q value will be log n already there plus log n. So this value would be 2 times log n. And continuing this way, how many times it iterates? For I is equal to n, what should be q value, sir? N times log n. Okay. See, of course, we don't do this much detailed manner, my dear friend. By looking at it, we should answer things. Okay. By looking at the loop, we should answer things, my dear friends. Just because when I am teaching, I do not know what type of audience are here, because different types of audience keep on coming. So I doubt, so that's why I given details. Actually, how we solve it? This is log n and this is log n. So q value is log n. Q value by end of first iteration is log n. How many times you are iterating? N times. So it is n log n. You should directly answer this like this. By looking at the loop, you should answer it. Am I clear? So that is how it works, my dear friends. Am I clear? Hope you understand. So by the end of this, what is the return value of q? N times log n, which is option D, my dear friends. So this arrow goes here. Is that clear? Yes or no? Super. One more problem. It's also, see, such problems are very interesting. Okay. Some non-linear recurrence relations. Okay. See, do something is a recursive function. It is called with the argument n. So you can call it as time complexity of this do something as Tn. Time complexity of this do something function is Tn. Accordingly, you have to write the recurrence relation. Once you write the recurrence relation, that you have to solve it using your methods to solve recurrence relations. That's it. We already discussed different methods to solve recurrence relations, my dear friends. So this would be time complexity for this is Tn. Now what is the fate of this? For n less than or equal to 2, it is just returning 1, some constant work. See, constant work you can write theta 1, you can write 1, you can write c, doesn't matter, my dear friends. You write 1, theta 1. Sometimes based on your answer also we manipulate that, my dear friends. Anything is fine. 1 you write, theta 1 you write, c you write, asymptotically everything is fine. No problem. And for otherwise, that is for n greater than 2, what you are doing? See this carefully. You are calling same function with argument square root of n. You are calling same function with the argument square root of n plus, is it t of root n plus n or t of root n plus 1? T of root n plus 1 or t of root n plus n? Now what is this? What is this value? What is this value? 1 or n? See my dear friends, here you are adding n. Adding n is a constant work. Adding n is a constant work. See, generally what people write, they write t root n plus n. It is not n. You are just adding n, sir. Adding n is just a constant work, no? Adding 1, adding 2, adding 3, adding n, constant work. It is just plus 1. It is not n. If you are having a for loop from I is equal to 1 to n, or if you are calling a function which iterates n times, in such case you may get theta n, my dear friend. It is just a constant work. It is just a constant work, remember. So Tn value is t root n plus 1. You have to solve this recurrence relation. I'll quickly give you, because earlier I told you how to solve it, okay, because it is not about explaining the problems, it is about solving the problems. So let us solve this. Now what you do is, you take n is equal to 2 power k, make substitution. Then this will be t 2 power k is equal to t 2 power, see n power half, n is equal to 2 power k, n power half is 2 power k by 2 plus 1. Got it? Now you can just assume this as some sk, this is sk by 2 plus 1, because t of 2 power k can be taken as a function of k. So this is sk is equal to sk by 2 plus 1, sk by 2 plus 1. Am I clear? Of course, this also you can write, sir, t2 or whatever it is. Of course, see, when you are writing approximate answer, theta answer, you don't have to worry about that base conditions much, my dear friends, unless or otherwise it is very, very important. Okay. When it is needed, we write, otherwise directly by master theorem you are getting the answer. Why to trouble ourselves with again manipulating all those stories? Directly you can write, this is by master theorem. By master theorem, even I done master theorem separately, my dear friends, you can just go through it. By master theorem, what happened? This is what? Sk is equal to sk by 2. A value is 1, b value is 2. So you have to compare n power log a to the base b with this function which is 1. So it is n power log 1 to the base 2. Log 1 is 0, so n power 0, this is nothing but n power 0 which is equal to 1. And 1 compared with 1, both are of same order of growth. Both are having same order of growth. So when fn and n power log a to the base b are having same order of the growth, by master theorem, the sk, not it is t answer, it is sk value. The value of sk should be equal to what, sir? Log k. Very good, log k. But what is k, sir? Because when n is equal to 2 power k, see, you can write n in terms of k, k can be written in terms of n. What is k? K will be log n to the base 2. So it is log of log n. So what is the complexity, my dear friends? Log of log n. Means I am just converted this into Tn, my dear friends. Because answer was given in terms of k, convert back in terms of n. So what is Tn? Log of log n. Theta of log n. So what is the correct answer for this? Theta of, is it available? Yeah, D. That's it. Am I clear? So we practice many problems, and this is the inspiration for solving different versions of these problems, my dear friends. Okay. This is the very interesting important question which was asked in GATE in year, which year? 2007. Good problem. Got it? So mathematical. Hope you understand. Any doubts? Can ask me. See, sometimes problem looks very, very lengthy, but you just need to understand the basic idea, then you can answer. You know, this is just by looking at, you can answer this. What is asking? Consider the following C code segment. देख लिए, आराम से देख लो. Let Tn denote the number of times for loop is executed by program on input n. Some input n के ऊपर this particular program we are running. Which of the following is true? Which of the following is true? And if you see the options, here he is asking Tn big O answer and big omega answer. Big O means what, sir? Asymptotic upper bound. Big omega means asymptotic lower bound. Means maximum number of times this loop iterates and minimum number of times this loop iterates. If you can tell, answer is done. There is nothing more than that. So now you have to identify this for loop. You have to tell maximum iterations for this loop and minimum iterations for this loop. Maximum how many times this loop iterates, my dear friends. That is maximum. Don't worry about whether it is what it is doing. That is not very important here, my dear friends. Okay. Of course, if you want, you can trace it. Okay, but what very important is for I is equal to 2 to root n, you are varying from where to where, sir? 2 to root n in steps of 1. So it's like 2, 3 and so on up to root n. So how many times it can iterate maximum? Order root n times. So maximum number of iterations is approximately of order root n times. Minimum. See here if you observe, there is a if condition. If this if condition is satisfied, we are returning the value. Means you are coming out of the loop and you are coming out of the function. Function also you are coming out and you are returning the value, my dear friends. Suppose minimum how many times it can happen, sir? If this particular condition is true, you enter and you are returning the value. Okay, so minimum how many times it happens? Suppose if n is an even number, okay, or not n is even number, or okay, even number also. Any even number you are taking, what happens? Percentile 2. Suppose I is equal to 2, percentile 2 will be 0. So obviously this particular condition is true and you may get inside this particular if condition. See, once you enter the if condition, you are out of the function. You are out of the function. So minimum number of times this loop iterates is 1 time. So minimum is lower bound, my dear friends. So the lower bound is 1 and upper bound is big O. Am I clear? Minimum bound is 1 and upper bound is root n, sir. Am I clear? So Tn is having minimum upper bound big omega of 1. Am I clear? And maximum value is big O of root n, my dear friends. Am I clear? So this is the idea, my dear friends. Nothing more than that. This problem only about, identifying, okay, maximum how many times it iterates, root n times. Minimum, okay, if you enter this loop, oh, gone. So minimum 1 time also it may happen. So minimum is constant. Generally minimum is constant. You can write theta 1 or big omega of 1, my dear friends. So not big omega of 1, my dear friends. Because lower bound, minimum is lower bound big omega of 1, you have to write it. Is that clear? An array of n numbers is given where n is an even number. Okay, very good. The maximum as well as minimum of these n numbers need to be determined. Which of the following is true about number of comparisons needed? Okay, if you directly remember, you can directly write the answer for this, but we'll take simple example for this. N is even. We are having even number of numbers and this particular algorithm is doing what, sir? Maximum as well as minimum of n numbers you are finding. Okay, so we are going to use actually min-max algorithm, which is a divide and conquer based algorithm. I am not writing algorithm, but with 4 numbers, because even number he said, na, I'll take an even number, with that I'll explain this particular algorithm, then we write the recurrence relation, we solve the recurrence relation, say what is the correct answer for this. Simple logic. Okay, so let us take 4 numbers, sir. Any 4 numbers. 3, okay, 1, 7, 4. 4 numbers are given. Okay, so you call this min max with, these are the indices, sir. So we start with the indices, say 1, 2, 3, 4, these are the indices. Okay, let me use different colors for this. This is 1, 2, 3, 4 index. So you call this min max algorithm, I am just writing M, sir. You call this algorithm with this indices 1 to 4. 1 to 4 and you need to find the minimum and maximum, my dear friends. Then what you are going to do is, you are going to divide into 2 parts by taking mid value. What is 1 plus 4 by 2, sir? 1 plus 4 is 5 by 2. 2.5 means you always take floor of it 2. So you call the same min max with 1 to, that is index 1 to 2. For that you have to find minimum maximum value. Then again for remaining indices, that is 3, 4, you have to call from 3 to 4. See, it's not like 3, 4, sir. 3 to 4 indices. You have to find min max. See, whenever it is just 2 elements, you can just do one comparison and tell what is the minimum and what is the maximum. So from 1 to 2 index, what is minimum and what is maximum? From 1 to 2 index, minimum is 1, maximum is 3. So you fix, first you are writing minimum or maximum, you fix that. Here also from 3 to A4, what is the minimum? 4 is minimum, 7 is maximum. See, actually it is a base condition. You actually called that particular min-max algorithm with n is equal to 4. Now it is divided into 2 subparts where n is equal to 2 is a base condition, you stop it. You just make one comparison of the 2 elements, you will get what is minimum and what is maximum. Now this is what you call, you divide the problems, now you are conquering it. Means you compare these 2 subproblems, means you are combining this, divide, conquer and combine. Am I clear? You combine these 2 problems. Combine in the sense what, sir? This is a min-max problem for 1 to 2 index. This is a min-max problem from 3 to 4 index. Now from 1 to 4 index, if you want to find min-max, what you just need to do is the minimum you compare, minimum fellows you compare. Which one is minimum out of these two fellows? 1, 4, which one is minimum? 1, 4, which one is minimum? 1 is minimum. Again you compare maximum fellows. 3, 7, which one is maximum? 3, 7, which one is maximum? 7 is maximum. Am I clear? So you got min max. Am I clear? So what is the minimum number? 1. What is the maximum number? 7, my dear friends. And if you want to see what is the complexity of this algorithm, you have Tn problem which is divided into Tn by 2. This is half problem and this is half problem. So these half problems are recursively solved, and how they are combined. This half problem Tn by 2 plus Tn by 2, or you can write 2 times Tn by 2. How they are combined, sir? See, for combining these two fellows, I just need to do 2 comparisons. This comparisons, this minimum fellow need to be compared with minimum fellow, maximum fellow need to be compared with maximum fellow. Just 2 comparisons are needed for this. And this is the complexity when n is greater than 2, my dear friends. And when n is equal to 2, when you have only 2 elements, how many comparisons are needed? 1 comparison is needed, my dear friends. So your Tn, the time complexity of this would be 2 times Tn by 2 plus 2 to compare minimum fellows and to compare maximum fellows for n greater than 2, and for n is equal to 2 it is 1, or any other. For n is equal to 1, only one number, no need of doing anything, sir. Directly that number is minimum, that number is maximum. 0 comparisons are required. All of you able to follow? Is the idea clear? So you just need to solve this problem, my dear friends. You just need to solve this problem. Okay, means recurrence relation, you have to solve it. So if you solve this recurrence relation, I am just giving you outline of the recurrence relation, sir. This Tn will be, I just give you outline, I will not write complete derivation. Tn by 2 plus 2. So what is Tn by 2, sir? Tn by 2 is nothing but, again, in place of n by 2. So it is T2 into Tn by 2 square plus 2. So when you simplify, it is 2 square into Tn by 2 square plus 2 square plus 2, my dear friends. Okay. This portion I am removing because I want to solve here itself. Akhil Hoki. One second. Yeah. So now just if you observe this, this is what we mean by understanding the pattern. So if you understand the pattern, you can directly write Tn is equal to, how long you have to continue, sir? Let us continue up to 2 power k. So 2 power k, Tn by 2 power k. See, when it is 2 square, it is also 2 square. So when it is 2 power k, it is also 2 power k plus 2 power k minus 1 and so on up to 2, my dear friends. Now, if you take this n by 2 power k as your base condition, what is base condition? N is equal to 2. Let us take it as n is equal to 2. So what happens? Tn will be 2 power k. N by 2 power k is 2. So it becomes T2 and it is sum of geometric series, my dear friends. So that I will write it here, 2 plus 2 power 2 plus and so on 2 power k. First term is 2. Here we are having k, see from k to 1. How many terms are there? K terms, correct or not? So it is 2 power k minus 1 by 2 minus 1, my dear friends. Is that clear? Yes or no? So this answer will be 2 into 2 power k minus 1. Now what is 2 power k, sir? From this you can understand 2 power k is n by 2. So when you simplify this, 2 power k is n by 2. T2 is, what is T2? T2 is 1, so it is 1. 2 into, what is 2 power k? 2 power k is n by 2 minus 1. So when you simplify this, it is n by 2. This 2 to cancel, you get n minus 2, which is nothing but 3n by 2 minus 2, which is 1.5 n minus 2, my dear friends. So the number of comparisons is option B. Of course, it's a very standard result. You can remember some standard results. Number of comparisons required for min-max algorithm is 3n by 2 minus 2. Directly you can remember. If you want complexity, order n only. But if you want to know the number of comparisons required, the exact number of comparisons will be 3n by 2. That is nothing but 3 by 2 means what, sir? 1.5 n minus 2. Directly you can remember or you can solve it, my dear friends. Hardly it takes any time, my dear friends. Okay, like that. This is a very interesting problem. Okay. An unordered list contains n distinct elements. The number of comparisons to find an element in this list that is neither maximum nor minimum. C is not asking maximum or minimum. Previous one was maximum minimum. But this problem is to find one element which is neither maximum nor minimum. Any one element. Any one element. Suppose I am having 5 elements or all are distinct. Distinct elements he said na? Distinct elements he said na? 5 elements, distinct elements. I need to find the element which is neither maximum nor minimum. For example, if I am having 1, 2, 3, 4, 5, sir. 1 is minimum, 5 is maximum. I just need to tell one of these numbers. Either I should say 2, 3, 4. Anything is fine for me. My algorithm just requires one fellow who is very, very decent fellow. Who is not cheapest or who is not costliest. I want to hire one who is good, decent enough. I don't want to hire, see, I am a person who is hiring some people for my company. I don't want to hire the person who is having high cost. I don't want to hire a person who is having least cost. I just need one person who is having mediatory idea. What is the answer? What is the answer for this, my dear friends? You are all here? Any doubts? A.B. de Villiers, Akhil, Sanchit, who are all there? Some people are replying. Prajwal Devtar. क्या हुआ? Akhil Square. Akhil says C answer. See, this is the most logical question. I think A.B. de Villiers might be knowing it. Sanchita Das. It's a very tricky one, sir. Most interesting question it is. I like such questions. Traps. This is a trap question. And in our C programming series, we completed up to recursion, and tomorrow we are starting with arrays and pointers, my dear friends. Those who not started C programming, you can start watching those lectures, and from tomorrow onwards we are starting with arrays and pointers. Okay, almost 4-5 sessions will devote on arrays and pointers, then followed by structures, my dear friends. So that would be the idea. Of course, strings followed by structures. Yeah. Anyone? See, let me tell you answer for this logically. See what you need, sir. We have distinct elements. Suppose I am having distinct elements like 1, 2, 3, 4, 5 elements I am having. I need to find a fellow which is not maximum, not minimum. How many elements if I take? Okay, I am showing you the answer. How many elements if I take, I can find a fellow which is not maximum or not minimum? How many elements if I take, I can find an element which is neither maximum nor minimum? Can anybody tell me? Out of this, how many elements if I select, I can find a fellow which is neither maximum nor minimum? One if you take, how can you find, sir? Suppose one element which you taken is 1. It cannot be that, no? You select any 3 elements. Akhil, you select any 3 elements from this. You tell me any 3 elements from this list. You tell me any 3 elements from this. For example, you selected 4, you selected 2 and you selected 1. Find maxima, minima in this or write them in sorted order. 3 elements sorted order can be done in constant time, sir. 3 elements in sorted order can be done in constant time. Okay, 4, 2, 3, 4 you said. Okay, you can take 2, 3, 4 also. You sort them. Okay, you may not be taking them in 2, 3, 4 order. No, first you select 4, then you select 2, then you might be selecting 3. Na? Like that you may be selecting. What you do, you sort them. You sort them. So when you sort, ignore the first fellow. Ignore the last fellow. This is the one which you want. So, this question can be answered in constant time. If you want to find number of comparisons to find an element in this list that is neither maxima nor minima is constant time. Because finding minimum and maximum of 3 elements can be done in constant number of times, my dear friends. Am I clear? You can do it in constant number of times. Constant iterations or constant number of steps. So the answer for this is theta 1. Means just take any 3 elements, sort them, remove smaller and remove larger. You can find the number which is neither maxima nor minima. So the most interesting question it is, my dear friends. It is the most interesting question. Next one. This is also very interesting problem, mathematical. Assume that merge sort algorithm in worst case takes 30 seconds for an input of size 64. For an input of size 64, it takes 30 seconds. Which of the following most closely approximate the maximum input size of a problem that can be solved in 6 minutes? So, if it can solve an input of size 64 in 30 seconds, which of the following most closely approximate maximum input of size that can be solved in 6 minutes, my dear friends? Can anyone answer this? Okay. Okay. Let me answer. See, my dear friends, simple logic. We will do mathematically. Input size, what is the size of input? 60. And time complexity of merge sort in any case is theta n log n. Very good. Okay, very good. Sai Charan Yadav, very good, sir. D you are saying. Okay, but it may be wrong. Let us see that. Let me see that. Okay, so see, theta means what, sir? Some constant times of n log n. That is, some constant times of n log n is this. Okay, now when n is equal to 64, this time complexity is, that is for n is equal to 64, what is this time complexity, sir? 30 seconds. For n is equal to 64, this c n log n, that is in place of n, I should put 64. That is c 64 log 64 is equal to 30. Yeah, Venkateshwarlu, welcome back. After a long time I am seeing you, sir. C 64 log 2 power 6 is equal to 30. So it is c into 64 into 2 power 6 means 6 log 2, that is into 6 is equal to 30. So from this I can get the value of c, that is 6 5's. C value is 5 by 64, my dear friends. See, you found what is the value of c. Now, what is that he want? When the time complexity, that is Tn is equal to 6 minutes. 6 minutes means, because it is in seconds now, let us convert it into seconds. 6 into 60 seconds. That is 360 seconds. Then what is the value of n? A very simple mathematical problem, sir. That is, Tn means what, sir? C into n log n is equal to 360. Now it is given. See here, both n and seconds are given. We found c. Now n value you have to find because Tn is given to you. And you know what is c? C is what, sir? 5 by 64 into n log n is equal to 360. So what is it? N into log n is equal to 360 into 64 divided by 5. 5 7's 35, 5 2's. So n into log n is equal to 72 into 64. What is 72 into 64? Can anyone help me out? No one? (72 into 64). 7 6's 42, 28, 12, 40, 4 2's 8, 8 0 6 4. That is 4608. Very good, Akhil. Now you have to identify what is the value of n. One way you can do is, because n values are given, you can try with n is equal to 256. or n is equal to 512, n is equal to, like that you can compare and you can find the value of n is equal to 512 for this. 512 for this. That is the value of n, my dear friends. So what is the value of n? Size of input. So 6 minutes you can take, or you can sort an input of size 512, my dear friends. If you can sort an input of size 64 in 30 seconds using merge sort, approximately we can sort an input of size 512 in 6 minutes. That is the story, my dear friends. Nothing more than that. Of course, 6 minutes it takes for input of size 512. We should start all this, my dear friends. Generally, all this will happen in nanoseconds, like that. It's not like milliseconds, nanoseconds, like this. Just for problem purpose, he given like that. Am I clear? Hope you understand. Next one. See, for this problem and next problem, I'll directly give you the idea, okay, because we are not getting into the details, because randomized quicksort was the next problem actually. If you want to solve, actually detailed derivation need to be done. In class we can do it, but here we'll try to understand. For quicksort, please remember, sir, this is the best case recurrence relation, quicksort in best case, and this is the recurrence relation for quicksort in worst case, my dear friends. Some constant work, some people write T1, then theta n. So this is actually best case and this is your worst case, my dear friends. And this complexity is theta n square, not theta, this is theta, sorry, n log n. Best case is theta n log n. You can use master theorem to get this, and when you simplify this, this would be theta n square, my dear friends. But what is very interesting about quicksort is the average case complexity is also theta n log n. See, most of the algorithms perform, okay, most of the algorithm perform their complexity would be close to or equal to that of worst case. That is, they perform with their worst case complexity. The beauty of quicksort is mostly it will give you average case complexity. Even though the worst case looks like theta n square, the beauty of quicksort is it will give you average case complexity, my dear friends. Okay, here the question is simply which one of the following recurrence equations for worst case time complexity. Worst case time complexity is obviously B is the correct answer for this. B is the correct answer for this. And this is randomized quicksort. See, the idea of quicksort is we are going to select a pivot element, okay, or an element, whatever you call it, okay. You identify an element. That element you want to place it in its correct positions. So when you place that element in correct position, all the elements less than that will be in the left subpart and all the elements greater than that would be in the right subpart. That is the basic idea of quicksort, my dear friends. In randomized quicksort, what happens? You are going to select that pivot element randomly. Randomly you are going to select. Normally in quicksort, what happens? The pivot element is first element, sir. But in randomized quicksort, what happens? You are going to select that element randomly, my dear friends. So generally what they feel, randomly, because you are selecting it, that element won't give you this, you know, the partitions which are, you know, different partitions. That is, worst case partitions you are not going to get. See, worst case partitions means one side n minus 1 elements, one side 1 element. This type of partitions are called biased partitions, my dear friends. Am I clear? So we are going to get good partitions. That is what people assume. But there are some types of input even when you do randomized quicksort. For example, if all elements are same. For example, if all elements are same, even when you do randomly, you select element randomly, what happens, sir? You are going to get the same story, my dear friends. Am I clear? So that is the idea. So even if it is randomized quicksort, extension of quicksort where the pivot is chosen randomly, what is the worst case complexity? So generally people expect that worst case complexity may come down to average case complexity. Nothing sort of that will happen, sir. Worst case means there will be some cases where even the random element which you pick gives you the partitions of this type, that is n minus 1 elements one side and 0 elements other side. In that particular case, what happens, sir? It gives you theta n square complexity only. So for quicksort, whatever type of variations you take, okay, you take median element, sometimes people take randomized quicksort, people take whatever you take it, the worst case complexity for this would be big O of n square or theta n square, my dear friends. Please remember this. Am I clear? Of course, the derivation is there for this. We have beautiful derivation, but I can't do it now. Okay. Hope you understand. So now let us see some graph questions. Of course, there are so many questions. I just pick some good questions which we can solve here, my dear friends. Am I clear? Some good questions. There is a graph. Actually, this problem can also be asked under discrete mathematics, my dear friends. And when I do both, I generally don't do minimal spanning tree under discrete mathematics, because that part will be done in detailed manner in algorithm course anyhow, my dear friends. Am I clear? Now look here. GB a connected undirected graph with 100 vertices. How many vertices are there in that particular connected undirected graph? 100 vertices are there. And how many edges this fellow is having? 300 edges it is having. Now what is saying? The weight of minimum spanning tree of G is, so he created a minimal spanning tree. So T is the minimal spanning tree. The weight of spanning tree means what, sir? Sum of weights of edges. It turns out to be 500. It turns out to be 500. Now the question is, when the weight of each edge of G is increased by 5, suppose if you increase weight of each edge by 5, the weight of minimum spanning tree becomes what? So if I increase the weight of each edge by 5, obviously weight of spanning tree also increases, no? So the new minimal spanning tree weight is what? The new minimal spanning tree weight is what? That is the question. Beautiful question. Please answer this. See, actually you can see more questions asked from graph part, graph algorithms in algorithms course. Of course, recursion they'll ask you, and actually if you see, there is no question based on dynamic programming in these 3 years which I collected. Okay, there was no questions from dynamic programming, my dear friends. No question from dynamic programming. Okay, but graph algorithms, 100% you can find a question in any GATE paper for sure. 100%. They may link it with, like, discrete mathematics link may be there, or data structuring link may be there, but 100% they'll ask you a question. See, my dear friends, this graph is having 100 vertices. So graph is having 100 vertices. What about number of vertices in this spanning tree? How many vertices are there in this spanning tree? In the spanning tree also we'll have 100 vertices, my dear friends. In the spanning tree also we have 100 vertices. Okay. Now, if it is having 100 vertices, how many edges it is having? How many edges it is having? Spanning tree 100 vertices means 99 edges. It is having 99 edges. Now, each edge weight is increased by 5. So, the new weight or additional weight is, for, because each edge we added 5, so 99 into 5, that is 495. So the new weight or new spanning tree weight would be what? Old weight plus new weight, which is 995, my dear friends. So this is the weight of spanning tree if each edge weight is increased by 5, my dear friends. If each edge weight is increased by 5, the new weight is 995, my dear friends. Hope you are following it. Any doubts you can ask me, sir. If you are having any doubts, you can ask me. Otherwise, we already completed some very good questions. Okay. So next time when we meet, okay, topic wise when you do it, it would be more interesting. I know that, because there are some parts which most of the people might have not completed, so they are not compatible with this particular topics. Fine. And tomorrow morning we'll continue with arrays and pointers. So we taken some very good questions from algorithms which were asked from IIT Kanpur, my dear friends. So we'll call it a day. If you have any doubts, you can ask me. I am open for your doubts. Otherwise, we'll call it a day, my dear friends. Akhil, Venkateshwarlu, anyone? I think you are having some other preoccupied works. Fine. So that's all for today. Thank you. Tomorrow morning, C programming, sir. Okay. And you can join my Telegram group for updates and notes and discussion. Thank you, sir. This is my Telegram group, CS_Sridhar. Thank you.